The purpose of this case study is to describe the interrelationships between industrial design, product design, and plastics engineering, okay? And those three disciplines were carried from concept to production, and I call this integrated design. Resurrected so that the new president of the company wanted to transform it into a small handheld device. It gave me a lot of work. But the handheld device had to be essentially battery operated and perform all the functions of the cart-based system with the exception of the printer. Okay? And product design, you're really interested in the product embodiment or the shape of the product. And these are based on the function and the technology of the product. And they have to be, as you've heard today, many of the presentations have discussed user needs, market requirements, environments of use. These have all become familiar to you if you've sat through some of the previous presentations. So industrial designers are basically taking the function and the technology and interpreting it to satisfy those user requirements. We just talk about that. These are all considerations in the design of this particular product, and cultural influences as well. None of these can be underestimated. The very thing that you underestimate is the very thing that will come back and haunt you later on. And that will be the Achilles heel in a product. And then, of course, there are your marketing requirements. In the early part of a project, you know, when you design your needs, the awareness of the different phases of development will change, and it'll cause some of the specifications to change. So, but they have to change in a logical fashion, okay? But initially, you're trying to define a product function, the technology, both current and future. Designers are also very interested in the overall configuration of the product, which is dependent on the components. And then, of course, regulatory compliance. We don't want to forget about that. Key consideration. Package, okay? And that's what those boxes represent. Then we went through a study of orienting them in different orientations in space. We went to clinics, we talked to some top physicians and clinicians, having them compare this to the original product. This was of how the information in a previous product, which you see in the upper left-hand corner, how that information was presented to the user, and exactly how it was stored, and what is actually being analyzed, and how is it interpreted by the end user. And we found it to be incredibly convoluted because it's more of a central storage system, and then how it would be retrieved from there. So it's a fairly complicated, independent study that was running in parallel with the embodiment of the product. Exploring the possibility of using a standard display from either an iPhone or a tablet, and integrating these devices in with the technology, okay? And that's what you see here. You'll notice extremely different form factors, and we did this intentionally to explore how and what method or technology would be most appropriate for the product to get to this point, okay? And then all of a sudden, we quickly realized that the form factors, you know, follow the form following function to a great extent, but also it has to have some relevance to the end user. So I came up with the idea of maybe using a camera as a metaphor to embody the technology. Uncomfortable, because we loaded it so that it would simulate the weight, and by this time it was up to about 3 or 4 pounds. They were now finding it awkward to handle and grip. So we interjected, if you look at the far left picture, there's just there's a handle just on the right side of the device. And then modeling it in the computer and applying it to the prototype and verifying the design. And then we came up with a perfected embodiment, at least from a conceptual standpoint, of what the product should be, all right? People that we interviewed. And at that stage, we had there's a huge gap between the prototype and the production. I am from a concept to a production product. minimizing gaps, understanding tolerances, and minimizing the number of crevices. I'm involved in this translation with a product that's primarily plastic, which is the case here. The material selection is a critical step in that evolutionary development to basically replicate the design you're trying. In the case, the plastic also had to be easily bonded. So some of these requirements are conflicting, okay? And with the hundreds of thousands of plastics on the market, it's virtually impossible, okay? And this is what I mean by this, maintaining design intent. These handles you can't injection mold. You can't mold that part conventionally, all right? And also, we had specified an elastomeric wraparound around the screen to prevent water from going in, behind the screen when you're cleaning it. So how do you get the seal around it? How do you put the two parts together? Well, if you look at this part, it has these little thin ribs these are light emitting diodes that went around this circular pattern here. When you take a plastic material and depending on how the part's gated, the material will knit. And what I mean by knit, it flows through around those openings, and then it sort of bonds as it comes together. And those points are weak points. So you don't want to have those in the middle of a thin web like that because it'll break. But if you gate it in the middle, as I'm showing here with that little purple dot, and it flows out the other way, you don't have any knit lines in the weak spots. So ideally, it would have been great to mold it as one piece. But that's something we had to look at. How do you do it? Because you can't do it conventional injection molding. Another way to do it was to mold it like you have, like you see with a power tool, mold it in 2 pieces or 3 pieces, where you have a front handle. That's why I colored it in that blue color, which would have to be then assembled. You'd end up seeing screws, okay? And the thing would look like this. It would look like a mess. It would totally ruin the aesthetics of the product. Plus, to clean it would be a nightmare, all right? And from a structural holder in a country that could do it. And I did quite a bit of research. The mold happened to be Mac Molding. I think they might be here at the show, I'm not sure. But they did a fantastic job. Now we had to change the geometry of the part ever so slightly. So that, see that picture in the upper left-hand corner? The sort of orange colored and blue? That's how the part your partner, whether it's a molder or a sheet metal supplier or I don't know, a PC board supplier, doesn't matter who that vendor is. You want that vendor to be your partner. When I was younger, I was not that smart, and I used to be quite adversarial, and I used to tick everybody off. Numerous iterative steps in your checks all along the way throughout your development process. You can assure that the guy or the man or woman who's assembling this thing at the end of your ingenious design is able to easily build it and reliably put it together consistently from time to time to time without having to be. Adding date stamps to your parts for injection molding is a critical part of anticipating how to track or trace parts once they're in the field. So if there's a failure or any type of problem, you can trace it back to a lot of material and a production date. And that's what that little date stamp is in the right-hand corner. This product had an optical engine in it, which was quite sensitive. So we actually isolated it in this elastomeric cocoon, so to speak. And that entire subassembly was actually press fit into the body of the unit and suspended in there. It was compressed in place, so it was actually literally floating inside the unit. So, and when when you all tested the product, the production unit, they dropped it onto a concrete floor from like 3 or 4 feet, and it bounced, and it bounced all over the place, and they picked it up and it still worked. They said, "We've never seen anything like that." So, if that was hard mounted to the body, it would have probably failed. It was a small range. In the end, that guy to the right, he's a good friend of mine, and he and I, he was the visionary in this product, and he's responsible for pulling it off in terms of putting the whole thing together. And we were fortunate enough to share the silver award for the MD.